This micro-credential deals with network planning and design and consists of 5 targeted skills. This targeted skill is about fiber optic networks. An alternative to copper media is fiber optic cable. Fiber uses light instead of electricity to transmit data. It has several advantages over copper media. These include higher throughputs, transmission over longer distances, and immunity to electromagnetic interference (EMI) and radio frequency interference (RFI). Fiber optic cable is made up of 4 components. The first is the innermost component that is a thin glass fiber between 9 and 62.5 micrometers in diameter. It is known as the core. The second component is a coating called cladding. It covers the core and is designed to stiffen and protect the fiber as well as reflect any escaping light back into the fiber. The third component is a fibrous material like Kevlar that is used to give strength to the cable. It is called the primary buffer. The fourth layer is the outer insulating jacket, which protects the cable and holds everything together. Fiber optic cable also comes bundled with multiple cores instead of a single cable for multiple connections. Historically, it has taken 2 fibers to support full duplex transmissions. That means sending and receiving at the same time. Bidirectional, bi-die transceivers installed on each end of the connection enable full duplex communications across a single fiber strand. There are 2 types of fiber optic cables: single-mode fiber, SMF, and multi-mode fiber, MMF. Single-mode fiber consists of a small core of 8 to 10 microns and uses a laser as a light source. The laser generates an intense light that travels a single path through the fiber with minimal reflection and allows it to travel unrepeated farther than any other media, over 6 miles. Multi-mode fiber is constructed in the same way as single-mode fiber. However, the core diameter of multi-mode fiber is usually 50 or 62.5 microns and is much larger than single-mode fiber. While single-mode fiber uses a single intense light source, multi-mode fiber uses pulses of light generated by a laser or light-emitting diode (LED) to inject signals at different angles. Because of the angles, there is more reflection and therefore more attenuation, a weakening of the signal strength. This limits the distance to 1,800 feet unrepeated and makes it best suited for backbone connections within buildings or supplying fiber to the desktop. Both single-mode fiber and multi-mode fiber are capable of data transmission rates much faster than any other media. But the cost of fiber optic cable is much more than that of copper. Because of this, fiber internet is not available in all areas. However, internet service providers, ISPs, have been very creative in pushing fiber as close to the customer as possible, and the internet backbone has become almost exclusively fiber. To get fiber as close to the user as possible, ISPs are implementing versions of a passive optical network, PON, which uses a single fiber to a neighborhood splitter, then individual cable runs to each final destination. Passive optical networks use wavelength division multiplexing, WDM, to allow multiple signals to be carried across the same fiber, then separates the individual data streams to be sent to the proper end user. There are 3 different variations of passive optical networks. The first of these is fiber to the neighborhood, FTTN. In this variation, the ISP runs fiber to a neighborhood junction box, then individual runs to each customer. An implementation like this will allow a single fiber to be shared by several hundred customers. A second implementation is called FTTC, or fiber to the curb. In this implementation, fiber is run to a junction box on a nearby pole or equipment cabinet. This implementation allows a single fiber to be shared by a few neighboring customers. The third implementation is called fiber to the building, FTTB. In this implementation, fiber is run to an individual home, business, or apartment building. This implementation allows for a direct connection to each customer or a very small group of customers. In this micro-credential, the two primary types of fiber optic cable were discussed: single-mode fiber and multi-mode fiber. Remember that the four components of fiber optic cable are the glass core, cladding, primary buffer, and outer jacket. Fiber optic cable is an assembly of optical fibers used to carry lights for various applications, especially concerning long-distance data and telecommunications.